All right, 8.43 misleading distributions. A business publishes a report saying that most of its employees earn at least $40,000 annually. When asked to show the distribution of salaries, they provide a probability distribution. Identify any flaws in the representation of the probability distribution. All right, what are we trying to do here? The company is trying to provide evidence, that their wages are fair. Okay, do you think the company wants to pay people lots of money? Probably not. So we can say that the company benefits from a distribution. Remember, distribution is just a statistical word for like a graph. A distribution that makes salaries of $40,000 to $50,000 appear significantly more than the lower amounts. Right? If you look at that histogram here, this number, it looks like it's really high compared to what's happening over here. But the way they scaled it, one thing I notice is that the x-axis, the scale for x-axis is misleading. Well, it seems like most bins, these are called bins down here, most bins are distributed evenly. The outliers. Okay, what's an outlier? Outlier, something way out there. Because the outliers are kind of hidden in the last bin. So let me try to draw mine. So what happens if we change the bins to 0 to 40K, right? And then you would have something like way up here. And let's just say you did 41 to 80K. And let's say you have it looks like that. And then you have 81K to 120K. Now my graph is kind of saying what? Oh man, that company, they don't pay a lot of money. Look where all the numbers are at. They're in the lowest bins to the far left. Does that kind of make sense? So just your scaling can really change things. Go ahead and try question number 5 below about basketball teams, and then go ahead and press play when you're ready. An athletic director made a probability distribution of the heights of her team's basketball players and distributed a flyer that claimed that the majority of the players on the basketball team are 71 inches or taller. Identify any flaws in the representation of the probability distribution. Look at the graph. What is she trying to say? My team is tall because there's a bunch of people in the taller range. You know, I'm almost 6 feet tall, and that would be 12 inches. Times would be 72 inches. So that's like a 6 foot tall player. Okay, what do we notice? They're missing something, and we have it up here. I call it an earthquake. It's missing an earthquake because they're not saying the data, the probabilities of 0 to 24%. Okay, so we can say the answer is what's wrong with this, what's the flaw in the scale, which axis? Of the y-axis, misleadingly shows the differences in probabilities. So I'm telling you, look right here. Let's actually make one so you can kind of see why. Okay, let's do this again. This time, I'm going to have it at tens. And let's see if this changes what it looks like. I can do the same thing. 61 to 65, 66 to 70s, 71 to 75, 76 to 80. And they're saying they're about 24. 24. And maybe this next one is 24. Does that make sense? Like, that's 0.25. And how about blue? Next one is 0.26. Do you see what they did there? And the other one's 0.26. So, is this now showing that all the players are like super tall on the team? For whatever reason, maybe she wants to tell the other coaches. No, they're all pretty much evenly distributed, but because she kind of lied with her statistics, right, using math to kind of convince other people otherwise, that was incorrect.
24 hours in a day, and I get to do math, hey hooray. Y equals mx plus b with Mr. Ng, we're making history. Pythagoras, Euclid, and Gauss learn the math and you'll become the boss.